Good morning. Myself, Prabharan J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is VLSI testing and its needs from Unit 4, that is Design and Testing. From the subject name is VLSI System Design. Let us discuss. Let I discuss about the need for VLSI testing. Before that, what is meant by VLSI testing? VLSI testing is the process of verifying that VLSI circuit function correctly and are free from manufacturing defect. Since VLSI chips contain million or billions of transistor, testing ensures reliability, yield improvement, and cost effectiveness. And What is meant by manufacturing defect? During fabrication, defects such as short circuit defect, open circuit defect, or bridging defect, all those comes under the manufacturing defect. And also stuccut fault. What is we will see in we will briefly discuss what is mean by stuccut fault, what is mean by stuccut zero fault, and stuccut one fault. For upcoming videos, we will briefly discuss. These defect comes under the manufacturing defect. This VLSI testing identifies defective chip before they are packaging and shipping. And next one is yield improvement. Okay. Yeah. Testing helps manufacturer analysis common defect pattern. Yield is nothing but the um, percentage of good chips. This percentage of good chip will increase by using uh, VLSI testing. We can improve we can find the uh, all those defect, like manufacturing defect. What is mean by which is stuck at open and stuck for short fault and stuck at zero fault and stuck at one fault, which these defect uh, are identified by using testing process, which improve the yield rate, which means percentage of the good chips. And third thing is quality and reliability. Chips are used in critical application like medical application or any automotive systems, aerospace, and communication equipment. Testing ensures long-term reliability and quality. And fourth thing is cost reduction. Identifying and discarding faulty chips early stages, as like wafer level testing, saves packaging and shipping cost. Okay, generally, VLSI testing essential to detect defect, improve yield rate, which means a percentage of the good chips, fault fault-free chips, which is called good chips. The percentage of good chips is called the yield rate. We can improve this yield rate by using this testing, VLSI testing. Also, it ensure quality and reliability, reduce cost, and validate circuit functionality. Without testing, the probability of fault chips entering the market would be mm, very high, leading to failures in real world applications. Okay, next is manufacturing test principle. Here you can see the uh, diagram, what is bridge effect and open defect and open at contact and patterning defect. Let me do one small activity. Find the value of the question mark position. Okay. Comment me your answer. Okay, let me continue. Next, we will discuss the manufacturing test principle. Uh, First one is controllability and observability. What is mean by controllability and what is mean by observability? Let me discuss. Controllability is nothing but the ability to apply a desired logic value to an internal node. This is called controllability. And what is meant by observability? Observability is nothing but the ability to observe the effect of an internal fault in the primary output. This is called observability. And second thing is fault modeling. Okay, what is meant by fault modeling? Use abstract fault models like a stuck fault and a bridging fault, all those things to represent physical defect. Testing focuses on these models to reduce complexity. And third thing is test pattern generation. Um, Generate test vectors, which is nothing but the input. Generate test vector to excite and propagate fault to the output, done manually or automatically, which means automatically means we can use ATPG. We will use ATPG. ATPG is nothing but the automatic test pattern generation. And fourth one is design for testability, incorporating special structure to improve test efficiency. Special structure, which means scan chains, boundary scan, and built-in self-test. We will discuss briefly in the upcoming videos about what is meant by scan chain and its block diagram explanation. All those things we will discuss in upcoming videos. Here design for testability under comes under the design for testability, the scan chain testing and boundary scan testing and BIST is comes under the design for testability. And fifth thing is test application. Test patterns are applied using ATE, which means automatic test equipment. Okay, chips failing, uh, the test is discarded. If passing, chips, uh, which means fault free chips, proceed to packaging or system integration. And uh, last thing is test coverage, effectiveness of a test measured by the percentage of modeled fault detected, which means high coverage, which is equal to more reliable product, which is called test coverage. Okay, some of the challenges uh, here, whenever we will do in manufacturing test, we will face a lot of challenges. Increasing transistor density, which more test data and large test time. Okay, if we increasing the density, then it require more test data and larger test time. And another challenge is high speed circuit require speed testing, which is maybe gigahertz frequency. Okay, whenever we will do in manufacturing test, the power consumption level is high in test mode. Okay, manufacturing test principle, uh, is based on fault modeling, controllability, observability, and structured test technique, which means design for testability, which is nothing but the DFT, and ATPG, which is nothing but the automatic test pattern generation, BIST, built-in self-test. Okay, and these all are the assessment of these lectures. First one is list out the need for test, and second question is how can you make test generation, what is fault modeling, and define yield and reject rate. These all are the uh, assessment question for this lecture video. Okay, if you have any doubt, you can ask me through the comment. We will meet in next video.